have this 30-volt battery, okay, and you have this 500 kilo ohm, and then you have here one resistance of 1 kilo ohm. This should be 500 ohm, okay, and here you have one more Gina diode, okay. This problem came in gate, and they given a resistance RL is equals to 2 kilo ohm. Okay. So they're asking what is V load and what is IL. Okay. So how can we approach this problem? Anyone? How can we calculate this one?
सर पहले ओपन सर्किट वोल्टेज निकालेंगे.
Okay, so this is given 20 volts and this is given you at 10 volts. Okay, now if these diodes are conducting, okay, then this voltage will get fixed. Okay, once these diodes are conducting, then this voltage get fixed. So automatically you know what is VL here, and once you know VL, you know the resistance, you know the IL. Okay, so before that, first we have to check whether these diodes are in working condition or they are conducting or not conducting. Okay, so now this circuit is basically double regulation. Okay, so if you have regulation here, if your in supply varies little bit, okay, so you want to load, you want a constant voltage, okay, regulated voltage, so you have one circuit and this will further regulate, so you have like a double regulation. But before that, okay, in this particular question these both are diodes are conducting, but we have to check first, okay, whether diodes are conducting or not conducting. Okay, so now there are two diodes, okay, both may be open, both may be conducting, one may be conducting, other is open, this may be conducting, this is open. So there are four cases. Okay, so we have to make sure, okay, all the four cases whether they are true or not. Okay, so just give me 1 minute. Mitlesh, tester do. So the first case, okay, so the first case I'm assuming there's both diodes are not conducting, okay, or I am calculating what is the open circuit voltage here and here. Okay, so once I want to calculate what is the voltage coming when they are open, so you have total resistance 500, 1 kilo ohm, and this 2 kilo ohm, so this becomes 3.5. Okay, so your current become in the circuit 30 upon 3.5 kilo ohm. Okay, so now if you solve this one, how much current is coming? Milliamperes. How much milliampere coming current? What is the current here? Okay, so this comes 6/7. Okay, and this go 10 raised to power 2, 10 raised to power minus 2.
8.6 milliampere.
How much? 0.6.
8.6.
8.6 milliampere. Very good. Okay, so this current is flowing when both are open.
3.5 how came, sir?
3.5 is this 1 kilo ohm, 2 kilo ohm, and this 0.5 kilo ohm.
Okay.
Okay, so if this calculation is correct, okay, this is 8.6 milliampere. Now you have to see this 8.6 milliampere current is coming here, so there will be voltage loss across this resistance. Okay, so how much voltage loss we'll get? So you have V across 500 ohm, that will be 8.6 milliampere into 500. Okay, so that will be how much? Tell me how much voltage is coming this. So this will come around some 4 point something volt. How much coming? 4.3 volt.
Yes, sir.
Okay. Now, so there's a loss of 4.3 volt. So remaining how much? 4.3 you minus here. So remain 25.7 volts coming here. And here we require 20 volts. So this voltage is very high. Okay. So this diode cannot be in non-conducting state because the voltage is coming very 20.7 to 7.5. Okay. Now similarly, here you can check. Huh?
4.3 volt, no?
4.3 volt drop is there. Once here you have 30, then you drop remaining coming here. So this much is coming here. Okay. And if you see loss here, so here loss is around 8.6 volt across because 8.6 current coming. So here loss will be around 8.6 volt. So 25.7 minus 8.6 volt. Okay. If I calculate the B across 1 kilo ohm, that will be 8.6 milliampere into 1 kilo ohm. Okay. So this is coming 8.6 volt. Now total is 30 minus this total. Okay, still this is greater than 10. Okay, isn't it? So this diode also cannot be non-conducting state when both are open. Okay, so that assumption that both diodes are open, that is wrong. That is wrong. That means this diode is conducting. Okay, once this diode is conducting, automatically here the voltage drop will be 20. Okay, so earlier open condition it was 21.7. But now once you fix this one, now here the voltage drop will be only 20. So obviously the more voltage will go there, go there. So here already was more than required 10. Okay, so both the diodes are in working condition. So I have opened both. I have checked. You can check both are conducting, disconnecting, this not connecting, this connecting, this not connecting, and you can find the voltage here. Okay, you will find that you are both the in this particular case both the diodes are in working condition. Are you getting what I'm saying? Okay, because this require only 10 volts, this require only 20 volts, and the voltage here is greater than 20, here are greater than 10. So both are conducting. Okay, so once they both are conducting, okay, here automatically VL voltage fixed, VL become your 10 volt. Okay, now you want your what is IL? So IL is simple, that is 10 divided by 2 kilo ohm. Okay, so that become your 5 milliampere, 5 into 10 for minus 3 ampere, that is 5 milliampere, and this was your answer. Okay, if you're in doubt, please ask.
Sir, when we use this double rectifiers, double Gina diode, when
Double
we
Gino
use,
diode, double Gino diode is basically when we don't use this is like a double regulation. If you want better regulation, one will give you regulation. If you have one more there, so here is coming regulated voltage. So here is fluctuation. Here you're getting 20 volts fixed. Okay, maybe somewhat less fluctuation than this one. If you do one more time, you get perfect regulation. Okay.
okay,
So number,
सर फॉर द सेकंड लूप
हाँ.
फॉर द सेकंड लूप जब हमारा फर्स्ट जब कंडक्टिंग हो गया तो
हाँ.
उसने तो 20 वोल्ट फिक्स कर दिया ना.
Yes. Yes.
तो हमने 25.7 लेके उसमें से किया ना माइनस.
पहले चेक कर, पहले तो पहले चेक किया ना. अब तो कंडक्टिंग है. अब तो कंडक्टिंग है. Okay. Now automatically you can see 30 here, 20 here. Here it will be 10. Loss of 10. Okay. So here how much will come now? There 20 will come. Okay. Now 20 will come. Then now you see 20 here. If you want 10 here, so remaining 10 will come here. So that you have to check, na? You have to open like this. You're saying we have fixed this one. Okay, let us we have fixed this one, and this is open, isn't it? You want this one?
यस सर यस.
Okay. Now you're saying this is conducting, this is not conducting. Now again check the voltage. How much voltage coming here? Check. Check how much voltage coming. So here the loss is 10. You're getting 20 here. Now this 20 volt will go here and here, isn't it? So
Yes.
20. So I want how much I want here. How much losses across to this 2 kilo ohm? So you have 20 total 20. Okay, that will be distributed between RL. So how much is against upon RL? So RL is your 2 kilo ohm, and this is your 3 kilo ohm. Okay, so how much? This is 40. 40 divided by 3 is how much? Something. How much? Is more than 10, isn't it?
13.4.
So this is more than 10, obviously. Okay, so if I'm assuming this conducting, this must be conducting. Okay, you can do another case. You say this is conducting, but this is not conducting. Okay, then again you can find what is happening. Okay, again you can check. You will find both will conduct. Okay. Now, if you want, you can check this one. You say this is conducting, this is not conducting. Okay. So now here you have 10 volts here. Okay. Now again the current is coming here. Current is coming here. Current coming here. Here 10 volts. So you can see how much. So 10 is here. So this means 20 should be here. Okay. 20 should be here. So you can check how much is coming here. 20. If 20 getting here. So 20 divided by current will be how much? 20 divided by 1.5 kilo ohm. Okay, this will be your current. Now, how much loss is across 500 ohm? 0.5 kilo ohm. Okay, so you can check. This will be 1, 3, some 6 volt will be lost here. So remain 30 minus 6, 26 will come here. Okay, so in any case, you check the diode. Both diodes are in working condition. Okay, so in working condition, this is fixed 10 volts, and 10 divided by 2 kilo ohm, 5 milliampere your IL. Okay, I hope it's clear. If still doubt, please let me know.
Yes, it is the standard method. Means first one should be considered open, and then check off sequence, or in any way.
You have to check all the things. Na? You have 4 cases. both are not conducting. You assume both are not conducting, but then you have to find voltage. But that assumption was wrong. Then you say this is conducting, this is not conducting. Then you say this conducting, this is not conducting. Okay, all the assumptions are wrong. So remain the final objection. Finally, left option is both are conducting. Okay, you have to check one by one. Okay. So now so far we are doing now varying load, general diode for varying load and varying input condition. Varying input conditions. Okay, both are varying. In that case, what should I do? Okay, for example, I have a question which also came in exam. Okay, so you have your input condition also varying. Okay, for example, it's varying by 15 to minus 20. Okay, and then you have a Zener diode here. Okay, this is 6.8 volt. That is VZ, and you have here RS, and here they given you that load current also varying. Load current varying means they are changing your resistance. Load resistance also they are changing milliampere to 20 milliampere. Okay, so both are changing. In that condition, how can we design a circuit, a Zener diode circuit? Okay, that means if both are varying, then what is the value of RS? Okay, that is called varying load and varying input conditions. Okay, this is also called worst case condition. A worst case condition. A worst case condition means that here you have a minimum volts and here you have maximum load current. Okay, so in those case, okay, how can we solve the circuit? So for those questions, you remember one formula. Okay, just apply the formula. Okay, you'll get the answer. So here, now suppose here, if here suppose in this particular case here V load is varying from V minimum to V max. Okay, now once I fix here V minimum value here, okay, then automatically there is the limitation of RS here, because what here you I is what, if I want current I here, okay, what is I? Suppose here is this V minimum and this is minus VZ, that is RS in the circuit, isn't it? V minimum minus VZ, remaining voltage will come here. If I divide by this voltage difference by RS, I get the current. Okay, or opposite, if I say I want RS, so RS will be V minimum minus VZ upon I, isn't it? And this is V minimum and minus VZ, and I know, okay, this IR is equals to my IZ, okay, IZ minimum plus IL max, or you just remember that is equal to IZ plus IL. Okay, I'm not putting minimum maximum, so you say IR, I know that is equal to IZ plus IL. Yes, huh?
Why V minimum only we have taken input?
I'm 1 minute, no? I'm telling. So we have to design the circuit. Okay. So once I have, suppose I have fixed, this is the worst case, na? First case, I have fixed this one, and here I want this diode to conduct. So automatically I have given 15 volts and some voltage here left. See, some voltage is developed here. Remaining voltage is coming here. Now suppose if I keep increasing the resistance, what will happen? Here the voltage drop become more. So here voltage drop become less, isn't it? This, suppose this voltage is fixed. Now
Yes,
if I keep on increasing this RS, the voltage drop across this will keep on increasing, and one condition will come that this diode will become non-conducting. Okay, so there is a upper limit of this resistance. Okay, if this resistance is more than this upper limit, then this IZ will become 0. Okay, this IZ will become 0 in the upper limit. There should be minimum current. If RA this resistance above a range, then automatically this will make this diode to come out from this breakdown conditions. Okay, so this will not be conducting. So there is a maximum limit of this one. Okay, so I can calculate that RS max. So RS max should be equal to a minimum current which required diode to conduct should flow there. So IZ I can write here IZ minimum plus, once this is minimum, automatically this become max, IL max. Okay, so you have given varying input condition, you have been given varying load conditions. Okay, you have to design the circuit. That means you want to know what is the value of RS, what is the maximum and minimum value of RS. Okay, so here you can get the maximum value of RS for V minimum. Okay, now suppose next time you are taking here V max. V max is how much? V max is how much?
20 volt.
Now suppose I'm taking here 20 volt. That is my V max. Okay. Now what can happen? Now if you apply V volt here. Now if I reduce this resistance beyond a particular limit, okay, now automatically here voltage loss is voltage is high, because 20 compared to 15 here voltage is high. Okay, now suppose I reduce this resistance, keep on reducing this resistance, so what will happen? This resistance will be keep reducing, and finally what will happen? Current I will be keep on increasing. So what will happen? When this current will increase, automatically this current will also increase. Okay, whenever in this circuit you increase this voltage, automatically this current increases. If your load is fixed now, so all the current will go here. Are you getting? So here current can go above Z max. That will also burn out this Zener diode. So there is a minimum limit of this one also. Okay, minimum limit is that here it should go max, IZ max current should go. Okay, I'm designing circuit. So RS minimum should be given by this formula: V max minus VZ. Okay, IR. Okay, IR, that will be V minimum, so V max minus VZ, and that should be your I Z max. Okay, plus once it is a max, it will automatically become minimum. Okay, so whenever you have been given this varying input condition and varying load condition, using this formula you can calculate what is the resistance required in the circuit. The resistance should be between these two limit. Okay, it should be greater than RS minimum and should be less than RS max. Okay, in that condition you can, this circuit will operate. That means your GINA diode will work as a regulating. Okay, in these particular resistance cases, in given voltages and given load currents IL max and I minimum, okay, you can find what is the resistance should be present in the circuit. Is clear?
सर सेकंड जो आपने लिखा ना RS मिनिमम,
हाँ,
उसमें से जो IR का एक्सप्रेशन लिखा ना वो समझ में नहीं आया. IZ मैक्स ही क्यों लिया और IL?
भाई आई मैक्स इसलिए लिया भाई, जहां यहाँ मैक्स लगा दिया मैंने तो यहाँ पे कुछ करंट फ्लो कर रहा है. ठीक है, अब मैंने इसको कम करना शुरू कर दिया तो ये करंट बढ़ना शुरू हो जाएगा ना. तो करंट बढ़ना शुरू हो जाएगा तो करंट को मुझे मिनिमम रखना है, करंट को मुझे मिनिमम फिक्स रखना है. ओके, सी सपोज मैंने यहाँ पे रेजिस्टेंस फिक्स कर दिया और अब मैं यहाँ से वोल्टेज बढ़ा रहा हूँ तो यहाँ आईएल तो बढ़ेगा नहीं, क्योंकि ये इसको फिक्स रखना है तो आईएल तो बढ़ेगा नहीं. तो पहले क्या बढ़ेगा, पहले करंट बढ़ना शुरू होगा और ये करंट it should not go beyond IL max. Okay, so what you do, simply you remember this formula. Wherever you get varying input and varying load condition, just apply this formula, you will get the answer. Okay, now here some case you can take IZ minimum also 0. Okay, so when you take IZ minimum 0, this will slightly more increase. This will be upper limit. Okay, so this your resistance should be lower than this one. Similarly here, okay, so this thing you to remember, that's it. And here you can take IL minimum is equal to 0, then this limit will also change. Okay, so basically in the question they will give you what is the IZ minimum and these values they will be given. If not given, IZ minimum is not given, then you can take IZ minimum equal to 0. That will not change our criteria. So I will show you some problem, then you will understand. So I'm erasing this one. Okay, still doubt, please ask any question. So basically I'm giving varying load and varying input condition. I'm designing the circuit. I'm finding what should be the limit of RS. Okay. So this problem came your net exam. They have I removed this, erase this one. Same problem. This came in your exam. They give you 15 to minus 20 volt varying. Okay, this is your RS is given, and they gave you GINA diode. Okay, 6.8 volt, and your IL value they are given. Okay, 5 milliampere minus 20 milliampere. So they are asking what is the value of RS? What the value should be? What is the value should be RS of the following options? So following options are 390. Second is 420. Okay. Third is 440, and fourth option is 460. Okay. So you find which of the resistance is suitable for this circuit. So what should I do? I should calculate RS max and RS minimum. Okay, so at least you calculate first RS max. What is RS max for this particular circuit? Calculate. What is the RS max value?
15 and 20 values है ना voltages के.
हाँ. 15 and 20. Find out what is RS max.
सर IZ मिनिमम एंड IZ मैक्सिमम निकालनी होगी.
तो IZ मिनिमम निकाल नहीं सकते हैं, कैसे निकालेंगे हम लोग? ओके,
1.64 kilo.
where RS value is what?
RS max.
No, RS max how do you find out RS?
Actual minimum IZ maximum कैसे निकालेंगे?
The RS maximum is your RS maximum. What is the formula for RS maximum? RS max V, you have to take V minimum minus 6.8,
Yes.
okay, and divide by
IZ plus
IZ
IL.
minimum plus
either minimum is not given, so you can take 0
Plus
and you take IL max 20 milliampere.
सर आईजेड मिनिमम तो निकाल सकते हैं ना
कैसे निकालोगे?
सर लोड करंट दे रखा है हमें और वोल्टेज तो 6.8 होगा वहां पे
तो लोड करंट तो ये करंट कहाँ पता है आपको? अभी ये करंट ये रेजिस्टेंस कहाँ पता है अभी तक? ओके, सो रेजिस्टेंस पता नहीं है, तो यू कैन टेक
14 आ रहा है
410 आएगा. वेरी गुड, 410 ओम इज कमिंग.
सर 15 माइनस 6.8 करके वीएस निकाल, लेकिन आरएस
हाँ, लेकिन आरएस का दे रखा है, तो यू विल टेक ये दिस करंट इज सैचुरेशन है. सो आई टोल्ड यू IZ sometime you can assume 0. Okay, that will change nothing. Okay, now that will only make this limit upper. Okay, so now this is 410 ohm, so your resistance should be below this one. This is Rmax, so your RS should be what? Less than your 410 ohm. Okay, so out of the following, which option should be correct?
390, first one.
First one. That's it. That's why they're asking. This is a worst case condition. Okay, so they're asking out of this which can be possible. Okay, now we may have to calculate minimum also, but they have not given the information, full information in the question. They're just asking out of this 4 which is possible. This is possible. Clear?
Means sir, 390 is the minimum one compared to us, so hence we are.
Compared to it should be less than 410. All other resistance are above 410, na? So
Okay,
this is a limit.
सर करंट वैल्यू 5 मिली एम्पियर से 20 मिली एम्पियर है ना?
हाँ, 5 to 20 है.
ओके सर. सर 5 मिनिमम होगा?
5 मिनिमम है, ये मैक्सिमम है. So there's one more question. All are RS max. Why they are asking RS max only? Okay. So they are giving you question. Okay, you have 22 to 30 volts. Okay, and this is your RS. This is your Zener diode. Okay, this is your 12 volt, and this is your, okay, this time they given you RL 140 ohm to 10 kilo ohm. Okay, and they are asking what is the value of RS max. What is RS max for this case? Okay, what is RS max? Apply the formula. Okay, so apply the formula and check it. Tell me how will you do? What is the value of RS max?
Sir, we have to find IL, no sir?
See, IL, yeah, IL you can find, yes. Okay, IL max you can find, na? How to find IL max?
सर मिनिमम रेजिस्टेंस मतलब RL मिनिमम बाय 12
V
वोल्ट
So you take this minimum is
EL 12
this,
लिखी.
12 lakh, very good. You can find. Okay, so RS max
93.4
no, you got check karo अच्छे से. 22 minus 12. Okay, and here you want IL max. Okay, so IL max is your nothing, that is your V load. Okay, BZ 12 divided by 140 ohm. So this become 10 upon 12 into 140. So this become 1400 divided by 12. How much is coming?
116.68.
93.3.
116 आएगा ना? Oh, 183, 116.68.
20 वोल्ट लेके कर लिया होगा.
68.
Sir, how the
हाँ.
how it's 22 volt or 20 volt है?
This
22.
is 22 to 30.
Okay.
Okay.
IL value how is sir?
IL value, IL max value is voltage is fixed. If you put RL minimum, you get IL max. If you divide by RL max, you get IL minimum. Okay. Okay. So let me give you one more question. Okay. So now this time the input values are varying from 20 to 30 volt. Okay. Your VZ is 10 volt. Okay. And take your IL load current IL value changes from 0 to 10 milliampere, and this time I'm giving you IZ max value. IZ max value is your 50 milliampere and IZ minimum value is 2 milliampere. Okay, so you have to tell me, now you have all the information, you can find what is RS max and you can find what is RS minimum. Okay, so I want to design a regulator with these things. Okay, so what should be the criteria for R? Okay, so I want to know what is the upper and lower limit of RS max. Calculate and tell me.
RS max 834 ohm.
Yes, and RS minimum. Okay, so the limit should come. RS should be between 400 to 833 point something. How much? Something. Okay, approximately 834. Okay, say it should be between this one. Check your answers coming or not.
Yes, sir.
Everyone is getting this answer.
384 RS minimum.
384. Okay, so 384. Okay, so your Zener diode is completed. Okay, now we'll see other applications of diode. Okay, like diode is used as a clipper and clamper. Okay, so diode clipper circuits. Okay, diode clipper.
सर आंसर क्या आ रहा था इसके पहले RL max और RL minimum का?
834 और lower limit में 384. Somebody told me that maybe change. Okay, so I around 400 to come, around 400 should come, 400 to 834. तुम्हारा क्या आ रहा है? फॉर्मूला तो लगा ना खाली.
हाँ सर RX max का आ रहा है, RL minimum का चेक करते हैं मेरा डिफरेंट आ रहा है.
Okay, now what is diode clipper circuit? Okay, for example, you have this input. Okay,
Sir, 400 coming, sir. Sorry.
you are getting 400.
RS minimum 400, sir.
Yeah,
IL
Yes sir,
minimum
RS minimum 400 आ रहा है.
Okay.
yes, it should be 400. I also answered 400.
Yes, 384 नहीं,
400 आएगा, please. 400 to 833.
834.
34, whatever. Okay, so now you have a resistance, okay, R, okay. So this is basically half rectifier circuit. So half rectifier is also a clipper circuit, okay, because when you take the output, some portion will be removed, okay. So clipping circuit means, okay, they will cut some portion of the, okay, or they will distort your input, okay. So for example, if I plot here my input and output, okay, suppose this is my input, okay, and if I plot my output, so in positive cycle, for positive cycle, okay, I'll get my V output, okay, V output equals to V input, because in positive cycle, if I assuming this is a idle diode, this will be conducting, this will become short circuit, okay, for positive cycle. So I get whatever the voltage is there, same voltage I get here. And negative cycle, this diode will open, this is a positive cycle, okay. For negative cycle, this diode will become open. Once it is open, there will be no current circuit, so your V naught for negative cycle, your V naught becomes 0, okay. So in output you get like half rectifier, that means some portion of the signal is clipped, okay. So this is your clipping applications, okay. Now same graph, so here I have told you that my graph is sinusoidal, okay, but it may not be sinusoidal, okay. It may be some linear curve, okay, any voltage. So suppose in that case, okay, so here particularly it is a sinusoidal, but it may not be sinusoidal. In that condition, how to plot a graph, okay. So for example, I want to plot V output versus V input, okay, anything, okay, V input can be anything, okay. So now just I want to plot V output versus V input, okay. So this is called your transfer function, okay. Transfer function means, okay, V output versus V input graph is called your transfer function, okay. Or transfer function is defined, transfer function represented by TS, or some book they represent by WS, okay. That is just your ratio of V input to V input, okay. Now if I plot V naught versus V input graph, okay, so you see positive cycle, whenever it is positive, I'll get whatever V naught will be equal to V input, isn't it? So that means in positive cycle, I will always get a line, straight line with a slope, is equal to 1, because V naught equals to V1, that is at 45-degree angle, okay. Now similarly, whenever I go in negative side, what will happen? I will not get any voltage, so this will be your 0, okay. So my transfer function value, okay, Ws is 1 for this particular circuit, okay.
हेलो सर, वीडियो पुश हो रही है
yes,
मेरी तरफ से हो रहा है, सबके साथ हो रहा है आपको?
हाँ,
सर वीडियो पुश हो रही है और चलने वाली आपकी वीडियो रुक रही है और आवाज भी रुक रही है।
okay,
नहीं सर, सुनाई दे रहा है ठीक से।
okay, वो सब आपका उधर से भी हो सकता है प्रॉब्लम हो. So this is your
Sir,
transfer function. हाँ,
say negative cycle diode will open ना,
और ऊपर मतलब करंट तो मिलेगा नहीं ना, वो V आउट, तो V आउटपुट
मिलेगा नहीं तो V0
V
0 हो
आउटपुट
जाएगा कैसा?
V0 0 हो जाएगा. हाँ,
W क्या हमने स्लोप WS से रिप्रेजेंट किया है कि W क्या दिखा रहे हैं? ओके ओके
ट्रांसफर सिंबल है, ट्रांसफर फंक्शन है, या तो TS लिखो या WS लिखो. सम बुक राइट TS, सम बुक राइट WS, ओके. ट्रांसफर फंक्शन है.
ओके सर, क्लियर.
Now suppose if I make this diode, if I put this here, I put resistance here, I put diode here, okay, this is my V output, okay. So can you tell me now, if I plot sine wave? Oh, okay. V input, what will be my V output in positive cycle? Positive cycle, what is the V output?
Same output will come, same wave.
Same come.
Yes, that would be conducting.
Diode conducting means what?
So there will be voltage drop across R.
And across diode,
The diode also, no?
how much voltage will come?
V in minus IR.
So diode is ideal, na? So across ideal diode, how much voltage is there? If diode is ideal,
0.
No
Zero.
voltage drop.
so then why you saying some voltage drop will be there? So in ideal condition, this become your what? Short circuit. There will be no voltage drop. That means for positive cycle you will not get anything. And negative cycle, what will happen? Negative cycle, when you come here plus, this is minus, this will be open. So now whatever voltage you do come here. So now V will be same like this. What are you getting here? Okay. So this is a circuit. Now if I ask you to plot
के लिए ऐसा क्यों
transfer
हो रहा
function,
है?
हाँ?
पॉजिटिव के लिए भी मतलब क्यों नहीं हो रहा है positive?
पॉजिटिव में तो ये शॉर्ट हो गया ना, शॉर्ट हो गया तो जीरो रेजिस्टेंस के अक्रॉस वोल्टेज ड्रॉप कैसे आएगा? शॉर्ट का मतलब क्या होता है?
हाँ, okay, voltage.
Okay. Now if I ask you to plot the transfer function of this one, okay, so obviously
तो क्वेश्चन में दिया था कि आइडियल डायोड है.
बोल तो रहा हूँ मैं आइडियल डायोड है. Okay.
ओके सर.
So if positive value of V input, there will be zero output, and negative you get V for negative voltage, you get equals to V output equals to minus V output equals to minus V input. Okay. Minus or plus? V
प्लस
input.
होगा ना सर, सेम ही आ रहा है.
Plus same ही आ रहा है. Plus input. Okay. So you get same thing. Okay. You're exactly same thing for both the conditions. Okay. Now let me tell you one more problem. Okay. I have this silicon diode. I'm replacing the diode with a silicon diode. Okay. So say I have a voltage source here, V plus, V minus. Okay. And here you have resistance, and you have diode here made of silicon. Okay. And here you have R equals to 0. Now, okay, now suppose you have a sine wave is coming here. Sine wave is coming here. Okay. This is your V input. So what will be your V output? Okay. So for positive cycle, what will be your, how to plot?
सर
Anyone?
0.7 लेंगे ना यहाँ पे 0.7 वोल्ट तक.
Yes, 0.7. Okay. So before I plot this one, let me plot this one. Okay, transfer curve. Okay, so once you know the transfer curve, it becomes easy. Okay, you can plot for any type of function. Okay, let me plot this for a transfer function. Okay, so this is my V output. This is my V input. Okay, now this voltage, this requires 0.7 volt. Okay, this diode requires 0.7 volt. So until when I applying giving voltage V input, until it is less than 0.7 volt, okay, this diode is in reverse bias, isn't it? This diode will be in reverse bias. This will not conduct because the minimum voltage it requires 0.7. Yes or no?
Yes sir.
Okay, so until you have 0.7 volt, so this will be open, so no current flow. So whatever voltage you apply, that will come here. So that means up to 0.7, whatever voltage you apply, okay, that will come in the input. Okay, after that what will happen? After that, once my voltage is greater than 0.7, this diode will become conducting and you can replace by battery. That means now this voltage will fix to 0.7 in forward bias. So after that, your voltage will fix 0.7 volt, isn't it? Okay, and once if I take negative value of this one, if I take negative value, this will be always open. Okay, this will be always in reverse bias. So whatever voltage you apply, that will come to here. That means this will come like this. Clear? Now similarly you can plot here. So up to 0.7 you get same thing. After that it will clip to 0.7. Okay, and then if you go down, this will become like this, and this will in negative cycle, this will come as it is. So this is your V input versus V input graph. So the advantage which you have when you have a graph like this, okay, transfer function, you can plot any function. You can draw for any function. I hope I'm clear. Is clear?
Sir, graph, can you please explain once more, sir?
Okay, so I'm telling this diode requires 0.7 volt. Okay, and I'm increasing my input from 0. So as I'm slowly increasing the voltage, what happened? At one point it will reach 0.7. Before, whenever Vi is less than 0.7, this diode is open.
Reverse bias.
Okay, this is open because it is require minimum voltage. You cannot replace the battery. So this will be open. That means whatever voltage you're applying, that voltage, same voltage is coming here. Once this become greater than 0.7, then this is conducting, and you can replace by 0.7. So this voltage become fixed. So this voltage become fixed. Okay, for higher voltage this become fixed. Again, when it comes to less than 0.7, it become open, and this is like this. And reverse bias, it is always open. Okay, reverse bias is always open. So what will happen? You get always whatever input you're applying, same input you get here. Okay, so
Sir,
here
if our diode is suppose they have given ideal one, then the graph as previous will come, na?
which one? If it's ideal, then previous graph come. Okay, okay. So I'm stopping here. Okay, this was the last question. So tomorrow we will discuss some more questions on clippers. Okay, so any question, please ask.
Sir, it basically cuts the voltage area. That's why it is known as clipper, na?
Clipper means it cuts it distorts your signals. Okay, it cuts some portion of the graph. Okay,
Sir, in negative cycle में ये मतलब open हो जाएगा.
In negative cycle it is open because the diode is reverse bias, na? This become positive, this become negative, this become okay. So now whatever voltage combined, this come like this. Okay, you are measuring like this. Okay, you are measuring like this, coming like this, that is negative. So whatever you are applying, same is coming.
सर एक बार ट्रांसफर फंक्शन एक बार बता दीजिए.
ट्रांसफर फंक्शन का मतलब क्या है? V आउटपुट और V इनपुट में. अब जैसे है कि आप यू आर स्टार्टिंग योर V इनपुट फ्रॉम 0, तो जैसे 0 से बढ़ रहा है तो सर्किट तो क्या है? सर्किट तो आपका ओपन ही है. ओपन ही है मतलब जो वोल्टेज दे रहे हो, जो इनपुट दे रहे हो, वही आउटपुट आ रहा है. दिस इज स्लोप 1. Are you getting? Straight line means what? They both are same. Once you reach 0.7 or above, okay, this become battery. Okay, so this voltage become fixed. So now if you increase anything, here voltage won't increase, here voltage become fixed.
And for negative cycle, it's decreasing.
Negative side is whatever you are applying, same coming in circuit with negative sign.
Yes, sir.
Okay?
Yes, sir.
Because like this same coming. Okay. So I'm stopping. Okay. Any question? Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.